Okay, we're up and live. Good evening, everybody. Welcome to vBrownBag. It's the specialty this evening is AWS certified SysOps domain 2.0 high availability with Bryan Krausen. Bryan, would you tell us a little bit about yourself?
Sure. Yeah, absolutely. Thanks for having me again. It's good to present on the vBrownBag for I think a second time here. I was part of the AWS Certified Solutions Architect series. I guess back in the fall sometime, and yeah, definitely excited to be on this one. My focus has been the last year or so focused on the AWS certs, and I'm focusing on getting the fifth one out of 5 here. So I've got 4 out of 5 and working towards the last one right now. So yeah, definitely excited to be on today.
Congratulations, that's great.
Thank you. Can you see my screen here?
Yeah, it looks great.
Okay, awesome. Let me move this out of the way here. Okay, cool. All right, I guess we'll get started here. So okay, there we go. I'm not going to talk a lot about me. Background, technical architect, work for Ahead. On Twitter, there's my blog. I'm working with AWS really since 2011. That's not to say I have 60 years experience, so there's kind of a gap in there where I didn't necessarily work on AWS, but I do have a lot of experience in AWS and kind of working towards doing more right now. So so Louisville vMug leader. I also lead the AWS user group here in Louisville. I started it, and I think we've had 4 or 5 meetings, something like that. So but yeah, as we talked about, certified SysOps administrator, high availability, right? So something that everyone should be keeping in mind, right, as the architects, really anything, right, but especially AWS. The fact that it's honestly just very easy to architect HA into a solution, on AWS. So following the blueprint here, right, domain 2.0 high availability. So really implement scalability and elasticity based on scenarios and ensure level of fault tolerance. So kind of touch on both of those tonight and kind of work our way through. So start with kind of scalability and elasticity. So I thought it was important to really define these and talk about each one, and then kind of the pros and cons of scaling up versus scaling out, and then we'll go into elasticity. So my silly drawings here, you look at it, you got users on the left hitting a load balancer. I guess I should have put like ELB, but really we're not necessarily talking about AWS specific. Scaling up applies to other things versus cloud, but so hitting a load balancer, right? Load balancing across 2 web servers, just simple infrastructure here. So as really the users increase, you're going to have resource contention, on the on your web servers, right? So as more and more users get added, CPU is going to go up, memory is going to go up, right? And they can only scale to so much depending on the resources that are allocated to the server. So eventually they're gonna run out of resources, right? And then the guy on the top right can start having issues, right? So they're going to start throwing errors. The application is going to be working as expected for your users. So scaling up really is just making the servers bigger, and then typically adding CPU, adding RAM to it, and kind of off you go there, right? You can support more users. So kind of the pros and cons, right, of scaling up. Generally, it's very fast, very easy, right? Especially if you're thinking about from a VMware perspective, right? You generally have hot add, right? So you don't even have to take an outage on the individual VM. Of course, in AWS, you generally have to shut down the instance, and you can just change the instance size. But to the second point there's generally no modifications to the application. So add more RAM, add CPU, whatever the new requirements are going to be, power that sucker back on, and you're off and running. Now, but generally because you're talking SQL, you're talking, Apache or something like that, where you generally go in there and modify the specific memory that those applications can utilize. So they're kind of applicable there. So, and then, one of the pros is you can generally scale up with CPU, memory, network, storage individually, right? So you don't have to go and add a bunch of stuff that you don't need to. Some of the downsides to scaling up, right? In AWS, like I mentioned, requires shutdown of the instance to change size. So you have to be prepared for that. Make sure that you either have downtime or you have some kind of HA. You can fail over to another instance while you're resizing that instance. In like a VMware or other on-prem infrastructure, right? You have the underlying host limitation. So, for instance, you can't scale. Well, shouldn't scale, right? A VM, more than the host has, right? Your host has 256. You're kind of limited to that, from the underlying host there. From an AWS perspective, right, the desired instance size may not be available. So if you are scaling from a T2 micro to a T2 large, right, but you only need more CPU, you're fine on RAM, right? You may get additional RAM that you're going to have to pay for that you don't necessarily need. So, having the T-shirt sizes in Amazon, may not be perfect, for you as you scale up. And then, from I guess everywhere perspective, it's hard to scale back down, right? So if application owners come to you and say, hey, we need more RAM, we need more CPU, etc. Generally, that size, those resources are going to stick with that VM, right? It's tough to go to the application team and say, hey, look, 2 months ago I gave you 64 gig versus 16 gig of RAM, right? I need to scale back down. Generally, that's going to be a fist fight to get those resources back. So I've been there, done that, successfully got resources back, but it's not easy. Scaling out, right, totally different, where instead of just making the boxes bigger, right, you're adding additional instances to spread the load across multiple instances, right? So same example here, more users, right? Kind of, memory fills up, but instead of making them bigger, what we're going to do is we're going to add a third host here, and then spread the load of the users across the new instances, and then generally resource utilization on the individual hosts are going to go down, right? So as you add more users, same kind of thing. All these guys go up, and then add more users, add more instances, and then again spread the load. So for these you can have in AWS, right? And we're going to talk about a lot of them, but there's certain things that you can trigger on to auto scale or to scale out, I guess. So if you hit 70%, memory utilization, if you hit X amount of CPU utilization, that can trigger a workflow to deploy additional instances for you to ensure that you can handle the usage coming in. So scale out, some of the pros and cons, right? Scale out is really kind of the definition of elasticity, right? So being able to scale up as your requirements need, and then scale back down as the requirements go back down, right? So only pay for what you pay what you need, and that's kind of the second point, right? Pay for what you need when you need capacity, save when you don't. So as additional requests come in, scale out web servers, sticking to our same example, as requests kind of go down, right? Maybe going in towards the middle of the night or something like that. Then start, removing instances and deleting them so you're not paying for the hourly charge. Typically you're not bound to an underlying host, the resources on that. So, as they're spread out across a larger cluster, right, you can pool those resources and generally have more resources allocated to your application. And then same thing, same concept, right? Increase throughput, so you're not restricted to the throughput of the underlying host, because now you're generally spreading them out across multiple hosts.
Brian, can I interrupt you for a second?
Yeah.
I've got a question from Graham. He's asking, Do the Amazon economics make it cheaper to scale out rather than scale up?
I think that's a good question. I guess, I mean, it all depends, right? I mean, I guess it would depend on how large your instance sizes are and the application. But generally, when we'll talk about elasticity and stuff in a couple slides here, but you can scaling up is generally cheaper because you can create a baseline of the initial requirements and then use something like reserved instances to get those for super cheap. And then you could use on-demand instances to scale up and down as you need, and only pay for what you need, and then delete those when it goes down. So, yeah, in a sense, I would say it's definitely cheaper if you scale out, because you can scale in, right, much easier. When you start scaling up, it's tougher to pull those resources back in when you need, because users are going to get used to that performance now. Developers can get used to that performance. They're not going to want to give that up.
Sure.
So it's just going to be a fight, I think, to do that. So but we kind of touch on that in a couple of slides when we talk about elasticity.
Thanks.
So the bad things, yes, cons on scale out, right? Generally, to scale out, there's typically significant application changes that are required, right? You heard of decoupling the application, right? So you start being more reliant on outside services, things like SQS, SDS. Start utilizing the additional services within Amazon and not have those services bound to a single application. So you have multiple application servers can grab messages off an SQS queue and perform some kind of work. And as that queue gets larger, you can have more instances, spin up and take care of that work. And then as it gets smaller, right, spin those back down. You don't have to pay for them. So, and then generally the infrastructure, the application becomes a little more complicated when you start decoupling, right? Because now you are relying on outside services, and you kind of have to know, what talks to what services are used for different types of different pieces of the application. So, and I kind of put this, how to scale out. Just kind of some examples that we talked about. Decoupling the application, utilizing things like bootstrapping or configuration management like Puppet Chef. A lot of this is going to be automation, right? So you're not going to want to scale out manually. It kind of won't make a lot of sense to do that. So you're going to want bootstrapping to configure the instance as it boots, or use something like OpsWorks or Puppet, something like that, to lay down the configuration after the instance is booted to lay down the application and make it make your application look like your application server. And then again, like I said, you want to use microservices where possible. Elasticity. So this is a drawing I got from Amazon. Just redid it on my Surface here, but so this is really like kind of the lack of elasticity, right? So this is what we typically do on-prem. So if you look at the blue line, right, that's our capacity. So kind of on the left here, the first flat piece, say that could be, we're gonna determine what our maximum capacity or maximum demand is going to be at any given moment, or we're going to buy at least that, right? Say for instance we run payroll on the last day of the month, and during that time we need additional resources. We need more RAM, we need more CPU, storage, etc. On that one day. But the other 29 days of the month, right, we're generally only running it 30%, 40%. So so the orange line on the left in the middle there kind of represents waste, right? So we're buying to maximum demand that we're going to have, but generally we're not running at 100% demand. So those CPUs, that memory, that storage is kind of sitting there spinning, or taking up electricity, cooling, all that. And it's kind of a waste of money, right? So as we kind of move to the right a little bit, as demand starts increasing, what do? We go out and buy, additional storage, right? We buy more servers, we buy more network switches, we buy, whatever we need. That's kind of the capital expenditure there. And then our capacity goes up, right? And we can handle more demand as it continues to increase. But at some point, we're still kind of at that flat line there, and demand is going to go up, when we're not expecting it, right? So if the company runs a Super Bowl ad or Black Friday or something like that, it could take longer to get to make the capital expenditure than you were expecting, and then now the demand passes the capacity, and now you have kind of customer dissatisfaction where your capacity can't keep up with the demand, so you start having application problems. Customers can't, check out on their website or whatever it is. And of course, there's another capital expenditure to kind of get above, bring the capacity above the new demand there. So that's kind of the lack of elasticity, and that's kind of what we do today, right, and generally on-prem. So what does elasticity look like? It's really being able to, use that scale out like we talked to before, and be able to increase the capacity as the demand increases. So you kind of see on the left where the arrow is increased traffic. At the same time the demand increases, we're using things like AutoScaling and CloudFormation and other types of automation to increase our capacity, kind of in front of the increased demand, and then make sure that we're staying just above it. And then at the same time, as traffic decreases, so this could be, the middle of the day, right? It's going to be, increased traffic is 9 o'clock, decreased traffic is 5 o'clock. So we can spin up servers in the middle of the day to ensure that we have enough capacity to meet demand. And then as 5 o'clock rolls around, people start going home, they get off the internet, traffic decreases, then we start spinning down servers to save on those costs. And this is where I was talking about before from the question. What we typically want to do is create a baseline of what your normal traffic would be, and then you can use reserved instances to save money on those baseline servers, and then as the traffic increases, use on-demand instances to be more elastic, right? Because you don't have, reserved instances generally have a 1 or 3 year contract on them, where elastic is, pay as you go. So, to save costs, use reserved instances at the bottom for your baseline, and then use on-demand as traffic spikes. So that was kind of elasticity, scalability there. I'm jumping into fault tolerance here. So I think that the first thing that comes to mind when you talk about fault tolerance in Amazon is the capabilities that you have to use all the data centers around the world that AWS provides. So, they've got 4 within the U.S. that you can use. One's GovCloud, and then one in Montreal, I think it is. They've got others going around the world, and then new ones coming up as well. So, the easiest way is to definitely use multiple regions, multiple availability zones, and we'll kind of go into that here. So this is right off AWS's website, right? It's really the definition of what availability zones are and what regions are, right? So kind of went over it in the Solution Architect series, but region is Northern Virginia, it's Oregon, it's Northern California, and it's Ohio, right? So those are your regions, and then inside each region there's an availability zone. So it's a distinct facility within that region, kind of distinct data centers, if you will, that are connected with low latency, high speed fiber, and they provide redundancy between one another. So if availability zone 1 goes down, hopefully availability zone 2 isn't affected, or 3. So that's kind of the definition there, availability zone. So what I did was, as we're designing applications, I kind of recreated over here. So as you're spinning up services and applications and stuff like that, the big thing you want to use is kind of your bare minimum is going to be, multiple availability zones. So kind of use a little automation on here, or animation, I'm sorry. So, as you spin up your first server, put it in this AZ1, second server, third server, right? So now you have three instances that are hosting your application, and they're in 3 distinct data centers. So as you continue to grow out, same kind of thing, right? So now we have 6 servers spread across 3 different availability zones. But what happens if we want to go multiple region, right? You want to do the same thing. The server 1 in this AZ, server 2 in this AZ. So now if you think about it, we've got 8 servers across 5 different data centers spread across the U.S., right? And I highly doubt the majority of people listening or customer has that many data centers that they have available to them and be able to spread their applications across all those data centers. So it's something to think about. Some words of wisdom here, right? So definitely, the first thing you want to do is architect applications to use multi-AZ. I mean, that's kind of the #1 rule when you're deploying, in Amazon. Multi-region is harder, but it's definitely doable, right? You can start using services like Route 53 to do primary, secondary records. You can do a lot of stuff with Route 53 to point to multiple load balancers across multiple regions to get multi-region. So it's a little harder because typically you have to have your application deployed in multiple regions. A lot of the services don't necessarily support multi-region replication, so you have to figure out a way around that. There are some services that do provide that, and we'll talk about that soon, but there's just something to think about there, and we'll talk about more about the multi-region stuff. So, architect with failure in mind, right? The cloud's not magic. It runs on hardware, and it's managed by humans, right? So, I mean, hardware fails. Humans make mistakes. Definitely not magic, right? So, I mean, you take the S3 failure on the end of February there. As much as I didn't want to really bring that up, it's a perfect point of what we're talking about tonight. I mean, you saw S3 went down in single region and caused a lot of problems. And you saw a lot of the websites and a lot of the services that we use every day that probably aren't using multi-region, HA. So, yeah. And then, my thoughts is, if your app fails due to single AZ failure, that's your own fault. It's not Amazon's, right? I mean, again, it runs on hardware. It's managed by humans. Mistakes are going to happen. Things are going to go down. But if you're deploying on Amazon, I mean, it's just incredibly easy to spread your application across different AZs and make sure that it's fault tolerant, at least from a single AZ perspective. So I put this on there. I thought it was kind of funny from Office Space, Jennifer Aniston. So her kind of bare minimum, right, was 15 pieces of flare. And as you're deploying and designing your architect, right, your bare minimum should always be 2 availability zones. So kind of moving on, I mean, the thought process on this was as we talk about AZs and regions, I'm going to touch on kind of the base services within AWS, talk about the individual pieces on where there's HA, where there's not HA, and some things I thought were important for the actual test. So, we're talking about EC2, right? The key thing to think about is as you're deploying an instance, right, you have to select a subnet for the instance to live in. And remember from the SA series that we did, a subnet is a single availability zone. So it's tough, to get, you can't have an instance spanning multiple AZs. So how do we get it, to span across multi-AZs? So the first thing is load balancer, or elastic load balancer, right? So send traffic to instances across all the AZs where your application is deployed within a single region. And it's important to remember that ELB does not span a region. It's only within a single region. You can use things like Route 53 to get around that. I don't know if that's the right term, but you can have Route 53 to point to different load balancers within the region. and it can help make those decisions on whether the application is up or not. Lots of load balancer, you know, the newer one released, I think, thinking around reInvent or something. Application load balancer that's generally layer 7, and then the classic load balancer is layer 4 there. So application load balancer is much newer. I doubt you'll see that on the test as of right now. The tests generally lag behind these feature sets. But, auto-scaling, we touched on that earlier before, but like I said, the definition of that is really elasticity in my mind. It allows you to scale and your application, you know, across multi-AZs, you know, and then it's continue to grow as the mini grows, right? So, like I said, scale up and down based upon demand, and I thought this is important while maintaining minimal application requirements. So, if your goal was to span, you know, 2 AZs, and you had a minimum requirement of 2 servers, right? So you're going to make sure that you, as you're setting up auto scaling, you're going to configure that to say, you know, my minimum is always going to be 2, and it's going to try to keep those between, you know, distinct AZs for you. But as you scale up, you can have a max number, right? You can go up to X amount, but as you scale up, right, it's going to try to load balance those across AZs. And then as you scale down, right, it's going to go down to back down to your minimum application requirement. So it's going to go back down to 2. So you're always going to maintain, you know, that HA pair between AZs at a minimum. And then, you know, EC2 volumes, right? So EBS, EBS is replicated across volumes. But remember, that's within a single availability zone. So there's no cross-regional replication there. Just something to remember. And then one thing I thought was important to point out, instant storage is ephemeral storage. So that is storage that is local to the host where the instance is running. It's not replicated, and as soon as you shut down that instance, right, that data is gone. So I'd say use with caution. There are workloads that, you know, can take advantage of ephemeral storage, right? Because it's local, it's much faster, but you can't rely on that data to be there. If the instance dies or something like that, that data is gone. So you need to be able to move that data off to something like S3 or another, you know, EBS volume. That's kind of S3, or S3, sorry, EC2. Let's talk about S3 now. So from an HA standpoint, S3 has a 11 nines of durability, right? So kind of put that in perspective. You store 10,000 objects. You can expect to incur the loss of a single object once every 10 million years. So that's pretty good for me. I don't plan on lasting that long, but it's pretty good durability there from my standpoint. And then, you know, just remember that S3 stores data across facilities, meaning AZ within the region. Availability, as is HA in a conversation, only 4 nines of availability. S3 is regional, so you can't choose AZ. So, you know, I thought it was kind of funny when S3 had its outage in February, and everyone was complaining that websites weren't multi-AZ. So, you know, just remember S3 is regional. You can't say I want an AZ1, I want an AZ2. It's, in order to accomplish high redundancy, right, you want to use cross-regional replication. So generally we don't have an outage like S3, which that was a result of a human error, right? They were trying to pull out some servers for maintenance, and he actually pulled out a lot of servers for maintenance. So if your application, you're trying to architect to cross, you know, to be able to support cross-region, you want to make sure that if you're using S3, you enable cross-region replication for your data there. And then Glacier. Glacier is also regional, right? Same thing, you can't choose AZs. So for redundancy, you want to copy data to vaults in multiple regions for redundancy. And I did kind of look to see if it was possible with lifecycle rules on S3, and I didn't see a way that you could create a lifecycle rule to say, my data in Northern Virginia, as it gets, X amount of days old, then also, move it to Glacier in, Oregon or something like that. And you could probably do that with, obviously with Lambda or, other services, but by default, the services themselves can't provide those features. Looks like my animation there's messed up, but anyway, networking, right? So kind of touch on this. Elastic IPs, those are public IPs that support remapping to mask failures, right? So if you have an application, say it's, I don't know, it's not, termed cloud ready. It could be, legacy app that can't be load balanced. You can map an Elastic IP address to it, and then you can have a secondary server ready to roll. If that dies, and then you can quickly remap that Elastic IP to the other hosts, and you don't have to worry about DNS and stuff like that. So you get the same public IP pointing to a surviving host. You kind of mask failure like that. Route 53 records mentioned before. So there's a ton of routing policies to support HA failover. There's a simple traditional A record, which we all use on a day-to-day basis, right? So you can always, if you want to manually, change the record to point to a different IP, or you can, do that with an API, something like that, if there's a failure. There's weighted, right? So move a percentage of traffic to one region or another. Many folks use this as testing, right, or kind of blue-green scenarios where you get two environments of your application, and you want to move a certain percentage of those users over to the new environment to test features, to make sure that everything's working right, and then you can eventually move 100% of traffic there, or move it all back, whatever you need. And then there's the failover. So those are typically A records, but what you do is you create a primary and secondary A record. And a lot of times those will be tied directly to an ELB. And then what you can do is have the ELBs, Elastic Load Balancers, do their own health checking on the servers that they're supporting, right? So if port 80 open is their keywords on the page that you want to ensure that it's working correctly. So the primary can continue to point to an ELB. Granted, the ELB is reporting back it has healthy instances behind it backing the application. As soon as all those nodes go down, whether that's on purpose, you want to purposely fail over, or there's just say a problem in Northern Virginia or something like that, then Route 53 starts sending folks to the secondary IP address. Granted, that ELB is reporting healthy nodes behind it. So, there's a way you could do HA using multiple VPNs or multiple direct connects. When I ran this with a customer, we had a point we were just doing VPN, but we had VPNs from our data center in Indiana, and then we had VPNs from our data center in Texas. Of course, our two facilities in Indiana and Texas had a WAN between them as well. So if there was a failure on one side, we could traverse the WAN and still get to Amazon and access our resources from using the private IP. So you can definitely architect your infrastructure that way. Then Internet Gateway, been sitting there for a while, right? So Internet Gateway is how you enable Internet access from your VPC. So one thing you've got to remember is there's only one per VPC. You cannot add multiple Internet gateways to a VPC. The cool thing is it's kind of automatically scaled for you, right? So it's horizontally scaled, as the demand increases, and it's both redundant and high availability or from an Amazon perspective. So they kind of take care of that for you. NAT Gateway, kind of the last piece on here, right? So NAT Gateway, a lot better using NAT Gateway, or it used to be you have to use the NAT instance, right? And spin up like a Linux AMI and then have it NAT for you. What's kind of sucked about that is you have to pay for the instance too. So now you can have NAT gateway. They kind of manage the OS piece for you, but a NAT gateway is typically tied to a single subnet, right? And a single subnet, of course, like we talked about, is within an AZ. So what you want to do is ensure that you have multiple NAT gateways, and then if a single AZ goes down, you can dynamically change your route to an either surviving gateway or a new gateway that you spin up to ensure that outbound traffic continues to flow. All right, let's see. So we get 2 more slides, so it just won't be too long tonight. RDS. So RDS for me I feel it was pretty important to know, especially for the SysOps admin test, right? So there's a lot of stuff in here. RDS is one of those services that does provide multi-AZ deployment, and we'll see in a minute, it also provides some cross-regional functionality as well. So multi-AZ deployments for MySQL, MariaDB, Oracle, and Postgres utilize synchronous physical replication, right? So that's important to know. Multi-AZ deployments for SQL will use logical replication, so actually use SQL mirroring to accomplish that. And generally what you're going to do is, as you're deploying an RDS instance, you're going to choose the initial subnet, or the AZ that's going to go in, and all you basically have to do is say, yes, I want this to be a multi-AZ, and it'll automatically put it in a second AZ for you. And then if there's a failover, right, it'll try to spin up a secondary for you if your secondary becomes your primary because of an outage. Aurora, kind of cool, replicates your volume 6 different ways across 3 different availability zones. So kind of crazy, very high availability built into Aurora there. So this is kind of some of the more important stuff, I think, from a test perspective. MySQL, MariaDB, and Postgres do allow the deployment of read replicas, and those are async. Those can be in the same region, or they can be in another AZ, or they can actually be cross-region. Postgres SQL is going to be your physical replication, and the other 2 are logical replication. One thing important here, that as you deploy read replicas, you've got to refactor your application to take advantage of the replicas. The read replicas are going to get their own DNS name, and what you have to do is, again, refactor your app to take advantage of those read replicas. So, if you have a business, some kind of reporting tool, you don't want to point that to your primary database, right? Create a read replica and then have it point to the read replica because, obviously a reporting tool is not going to be writing. It's going to be reading all the data. So something you can do there. You can have up to 5 read replicas per source database instance, so that's important to know too. And then from a read replica perspective, you can promote one to its own standard database if you need to. So if you need to do testing or something happens, you can break that replication and create another database from a read replica. Maintenance activities, this is important to know as well. Backups are taken from the standby node, so it eliminates IO suspension to the primary node. You may get a little more latency as the backup happens, but you don't get the IOs not suspended on the primary. And then during OS patching or DB instance scaling, right, they're applied to the standby first, and then the database fails over to the standby, and then which becomes the new primary, and then the secondary is upgraded as well. So DB instance scaling means you went in there and said, hey, I don't need this to be a T2 micro anymore, I need a T2 large now. So as it scales for you, it'll apply to standby first. So you will have an outage, and your outage will last just as long as it takes to fail over from the primary to secondary node. So something to consider there. And then really the last piece I wanted to touch on is high availability versus cost, right? So generally, high availability equates to extra cost. Depending on what you're deploying or where, you're going to have double the storage, right? If you need to enable cross-site replication for an S3 bucket, you're going to have to pay for that data in Northern Virginia and Northern California, if that's where you replicate it to. Double the instances, right? If you're going to load balance, you're typically going to have to pay for more than a single instance across different AZs. There are costs associated with the ELBs, costs associated with I put extra in there, EIPs. So when an instance is spun up, you do not have to pay for an EIP. But if you have an EIP that's tied to either an instance that is not running or an EIP that's not associated with an instance, Amazon will charge you for that. So it's something to be aware of. Determine the use case for application and business requirements. Not everything has to be highly redundant and highly available. So there's a fine balance between cost and high availability. And depending on the business requirements, they may be okay with a lower SLA to save on costs. So it's a case-by-case basis, and it's really all about the business requirements there. This I always thought was important. Test UAT, QA environments should look like production. The cool thing is in Amazon, it's super easy to do. You can even have different, accounts separately for dev and test so they can affect production. I always thought that was important. Folks testing on, infrastructure that was not like production and roll code into production. It doesn't either deploy right or act right, and they're kind of scratching the head trying to figure out why. It's because the test environment, doesn't mimic the production environment, right? So, as you mimic those environments like for like, it gives us opportunity to test HA situations without affecting production. For me personally, when I was on a customer, we had a large web farm, and we had multiple load balancers using VRP, for redundancy. But then on the development side, we only had a single load balancer, and I didn't like that because I couldn't test failover. I couldn't test a lot of the functionality with that. So we didn't have a like-for-like environment. So kind of went up the stack there and made sure that everything was corrected. And then as you have like-for-like environments, you kind of see how the application reacts and performs in the environment. Again, last thing we want to do is have our test environment running on T2 micros, and then or something larger, and then when you're going to deployment, put it on a different type of instance, and just it may not react or perform the same way as it did in test. And then lastly, mostly around costs, right? Use things like CloudFormation, Terraform tools for cost savings. So using tools like that, you can rapidly spin up, test, and spin down environments, very quickly. So you don't have to worry about, instances running all night, instances running all day, whatever. Use what you need to, get rid of it when you're done. And then things like we do, actually here ahead, we use Lambda to stop instances after hours or when they're idle, so we don't have to pay for those, right? So if your development staff, 6 o'clock every day, they're out the door, right? So 6:30, 6:15, something like that, you can have a Lambda function to go and stop all the development instances, so you don't have to pay for those overnight. So there's a couple things to think about for cost savings. So that's really it. That was, like I said, HA is, there's quite a few things to know, especially around the RDS. I think it's important, but kind of some just tidbits here and there that you'll have to know for the test.
Wow, Bryan, that was a lot of information in such a short time. Great presentation.
It was.
Thanks very much.
Awesome.
Let me
yeah,
ask
thank you.
our attendees if they've got any questions here at the end of the presentation.
Okay.
There were some questions throughout the presentation, but you answered them as you went. So let me just give them another minute or so. Well, I guess that's how thorough you were. You answered all their questions.
Awesome. That's always a good sign.
It is. It was a great presentation. Thanks again, Bryan.
Well, thank you very much. I appreciate it.
Well, we'll be looking for you again.
Yep, definitely. Yeah, I'll be looking forward to it.
All right. Thanks again, and have a good evening, everyone.
Thanks. You too, Chris.